Article 110.12 of the National Electrical Code states that electrical equipment and installations must be free from physical damage or defects that might impair safe operation or contribute to the risk of fire, electric shock, injury, or death. Furthermore, the equipment must be listed, labeled, or otherwise certified by a qualified testing laboratory. The ABB Isomax S Breaker is a circuit breaker designed to protect electrical circuits from overcurrent conditions. It is commonly installed in electrical panels to control electricity flow to various loads. The standard wiring configuration for the ABB Isomax S Breaker involves connecting the line voltage to the top terminals and the load to the bottom terminals. This configuration is not just common, it's generally required by the National Electrical Code. Wiring the breaker with the line voltage connected to the bottom terminals and the load connected to the top terminals is a violation of the National Electrical Code and is considered a safety hazard. It is not recommended to wire the breaker in this manner. To ensure compliance with the National Electrical Code and to maintain the safe operation of the heating, ventilation, and air conditioning or HVAC equipment, the wiring configuration should be corrected. The correction involves connecting the line voltage to the top terminals of the breaker and connecting the load to the bottom terminals. The National Electrical Code provides a comprehensive set of standards for electrical installations to ensure safety. Following these standards is crucial for preventing electrical hazards and ensuring the reliable operation of electrical equipment. One should always consult the manufacturer's instructions and relevant electrical codes when installing or modifying electrical equipment. Proper wiring and installation practices are essential for maintaining a safe electrical system. Firstly, always to energize the circuit before working on any electrical equipment. Secondly, use appropriately sized conductors and connectors for the intended application. Thirdly, ensure that all connections are tight and secure. Fourthly, properly ground all electrical equipment. Fifthly, protect electrical circuits with appropriate overcurrent protection devices, such as circuit breakers or fuses. Sixthly, follow all applicable electrical codes and regulations. Seventhly, only qualified personnel should perform electrical work. Ignoring these guidelines can lead to dangerous situations, including electrical shocks, fires, and equipment damage. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installation and is updated regularly to reflect current best practices and technological advancements. Its purpose is to safeguard persons and property from hazards arising from the use of electricity. Compliance with the NEC is often a legal requirement and is crucial for insurance purposes. The NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Understanding the NEC is essential for anyone involved in electrical work, from electricians and engineers to inspectors and homeowners. Firstly, the NEC specifies the types of wiring methods allowed for different applications. Secondly, the NEC provides guidelines for selecting the appropriate size of conductors for a given load. Thirdly, the NEC outlines the requirements for grounding electrical systems to prevent electric shock. Fourthly, the NEC specifies the types of overcurrent protection devices required for different circuits. Fifthly, the NEC provides detailed instructions for installing electrical equipment safely and correctly. The NEC is a complex document, but it is essential for ensuring the safety of electrical installations. There are many resources available to help you understand the NEC, including training courses, books, and online forums. One should always consult the latest edition of the NEC and any applicable local amendments before starting any electrical work. The proper selection and installation of circuit breakers are crucial for protecting electrical circuits from overcurrent conditions. Circuit breakers are designed to trip or open a circuit when the current exceeds a predetermined level. This prevents damage to equipment and reduces the risk of fire. Circuit breakers are rated in amps, which indicates the amount of current they can carry continuously without tripping. The amp rating of a circuit breaker should be matched to the ampacity of the conductors it protects. Using a circuit breaker with too high of an amp rating can allow excessive current to flow, potentially damaging equipment or causing a fire. Circuit breakers are also rated in volts, which indicates the maximum voltage the circuit breaker can safely interrupt. The voltage rating of a circuit breaker should be equal to or greater than the voltage of the circuit it protects. Using a circuit breaker with too low of a voltage rating can result in this circuit breaker failing to interrupt the circuit properly. Circuit breakers are available in a variety of sizes and types, including single-pole, double-pole, and three-pole breakers. The type of circuit breaker required depends on the type of circuit being protected. Single-pole breakers are typically used for 120-volt circuits, while double-pole breakers are used for 240-volt circuits. Three-pole breakers are used for three-phase circuits. When selecting a circuit breaker, it is important to consider the interrupting rating, which is the maximum amount of current the circuit breaker can safely interrupt. The interrupting rating should be equal to or greater than the available fault current at the point of installation. If the interrupting rating of the circuit breaker is too low, it can fail to interrupt the circuit properly, potentially resulting in equipment damage or a fire. Circuit breakers should be installed in a panel board or enclosure that is listed for the purpose. The panel board or enclosure should be properly grounded to prevent electric shock. Circuit breakers should be inspected regularly to ensure that they are in good working condition. If a circuit breaker trips frequently, it may indicate a problem with the circuit or the equipment it protects. In this case, it is important to investigate the cause of the tripping and correct the problem. Never replace a circuit breaker with one of a higher amp rating without first consulting a qualified electrician. This can create a dangerous situation and could lead to equipment damage or a fire. Always follow the manufacturer's instructions when installing and maintaining circuit breakers. Proper installation and maintenance are essential for ensuring the safe and reliable operation of circuit breakers. Grounding is a critical safety measure in electrical systems. It provides a low resistance path for fault current to flow back to the source, which causes the overcurrent protection device, such as a circuit breaker or fuse, to trip and energize the circuit. Grounding helps to prevent electric shock by providing a safe path for current to flow in the event of a fault. Grounding also helps to reduce the risk of fire by limiting the voltage rise on conductive surfaces. The National Electrical Code, or NEC, specifies the requirements for grounding electrical systems. The NEC requires that all electrical equipment be grounded, including metal enclosures, conduit, and equipment grounding conductors. The grounding system must be properly sized and installed to ensure that it can safely carry fault current. There are two main types of grounding systems: system grounding and equipment grounding. System grounding refers to the grounding of the neutral conductor of the electrical system. This is typically done at the service entrance, where the power enters the building. Equipment grounding refers to the grounding of the metal parts of electrical equipment. This is done to provide a safe path for fault current to flow back to the source. The equipment grounding conductor is typically a green or bare wire that is connected to the metal enclosure of the equipment. The equipment grounding conductor should be sized according to the NEC requirement. When installing grounding systems, it is important to follow all applicable codes and regulations. Improper grounding can create a dangerous situation and could lead to electric shock or fire. Always consult a qualified electrician when installing or modifying grounding systems. Proper grounding is essential for ensuring the safety of electrical systems. It helps to prevent electric shock, reduce the risk of fire, and protect equipment from damage. Overcurrent protection is another critical safety measure in electrical systems. It protects electrical circuits and equipment from damage caused by excessive current flow. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a predetermined level. This prevents overheating, insulation damage, and potential fires. The National Electrical Code, or NEC, specifies the requirements for overcurrent protection in electrical systems. The NEC requires that all electrical circuits be protected by overcurrent protection devices. The amp rating of the overcurrent protection device should be matched to the ampacity of the conductors it protects. Using an overcurrent protection device with too high of an amp rating can allow excessive current to flow, potentially damaging equipment or causing a fire. There are two main types of overcurrent protection devices: circuit breakers and fuses. Circuit breakers are reusable devices that can be reset after they trip. Fuses are one-time devices that must be replaced after they blow. The choice between circuit breakers and fuses depends on the specific application and the desired level of protection. Circuit breakers are typically used in residential and commercial applications, while fuses are often used in industrial applications. When selecting an overcurrent protection device, it is important to consider the interrupting rating, which is the maximum amount of current the device can safely interrupt. The interrupting rating should be equal to or greater than the available fault current at the point of installation. If the interrupting rating of the overcurrent protection device is too low, it can fail to interrupt the circuit properly, potentially resulting in equipment damage or a fire. Overcurrent protection devices should be installed in a panel board or enclosure that is listed for the purpose. The panel board or enclosure should be properly grounded to prevent electric shock. Overcurrent protection devices should be inspected regularly to ensure that they are in good working condition. If an overcurrent protection device trips frequently, it may indicate a problem with the circuit or the equipment it protects. In this case, it is important to investigate the cause of the tripping and correct the problem. Never replace an overcurrent protection device with one of a higher amp rating without first consulting a qualified electrician. This can create a dangerous situation and could lead to equipment damage or a fire. Always follow the manufacturer's instructions when installing and maintaining overcurrent protection devices. Proper installation and maintenance are essential for ensuring the safe and reliable operation of electrical systems. In summary, adhering to the National Electrical Code, ensuring proper wiring configurations, grounding practices, and overcurrent protection are all crucial aspects of maintaining a safe and reliable electrical system. The specific example involving the ABB Isomax S Breaker highlights the importance of following manufacturer's instructions and relevant electrical codes to prevent potential hazards.